Okay, I'd like to welcome everyone to the AIA New York Chapter Technology Committee event for September 2012. I'm the co-chair of the committee. I'm Paul Seletsky, and my other co-chair will be with us shortly, Erlene Hatfield of Bureau Happold. Before we begin, I wanted to thank ABC Imaging for their generous sponsorship of this event, and actually the last 7 years they've kept these events free for every month that we've had a lecture for about the last 7 years. So thank you, Charity Craig and ABC Imaging. And she's over there. We have pretty much a full house tonight, and it should be a very interesting evening with KPF. I guess everyone still thinks about 9/11 as a fairly somber day, which it is, and so we do want to pay our respects to those who passed away. Ian Atkins, who is one of tonight's speakers, asked, should I say anything? And I said, we are not forgetting what happened on 9/11. So we have dear friends in our hearts, and we still go on, and life still goes on. And tonight will be both a remembrance and a celebration for what's yet to come. So let me begin by discussing a little bit about how this event came about. I guess 12 years ago, 13 years ago, a colleague of mine, James Brogan, who at the time I think was with Hardy Holtzman Pfeiffer, said, hey, I'm the chair of this technology committee at the AIA in New York, and maybe you want to come to one of the meetings. I think I had just started with HLW, not too far away. We were literally across the street in terms of our offices. And thus began a very long and wonderful friendship with James Brogan, who is now the director of technology firm-wide for the firm, and has been with the firm since 2001. And so we go back a long ways, and it's not just professional. Our families have known each other, and James has visited me, and I visited him, and so we've had a long and wonderful relationship. And I realized after, I guess, about 10 years of doing these lectures that we've hardly ever had you guys speak. So we thought, this would be a great opportunity. It's the start of kind of the fall season of events, and so I'm very pleased that James got together the staff at KPF that's involved not only in digital design and digital technology, but also involved in the design process itself. And I think you'll see a lot of that tonight. Ian Atkins is a former colleague at SOM. Charlie Portelli is a former visiting student from Stevens Institute of Technology when I was at SOM, and we were doing a collaborative program with that school. And then we have a few other folks, Gara, who's involved with environmental performance, Justin Whiteford and Rafael Pereira. So there's a whole combination of things. But before we really begin, I did want to ask James to come up and say a few words. And I also want to thank him for being so gracious in getting this group together tonight. So.
Thank you, Paul. Thanks so much for the invitation. It took 10 years for you to finally accept my monthly pleas, but I appreciate it. Just really briefly, because I really want the folks who are actually doing the work to talk about the work, which is really amazing. I did want to just frame for a moment our technology efforts at KPF and kind of, I guess, more holistically paint a picture of what our goals are. When I started in 2001, really I felt my first challenge was to understand the business of how KPF worked, the collaborative integrative design process that they were really had developed over the decades before I started. And really to understand the design process, how it worked, and how to work collaboratively with our clients globally, internally, KPF, and with our clients collaboratively. So I kind of took that charge of looking at how the business worked and built the technology strategy around that. And it really comes down to three components, and really we'll talk really about one tonight, but three important integral components. Design technology, so the things you'll see tonight, taking parametric design, 3D modeling, kind of rules-based integration of the software tools, and how that reinforces our design methodology. Knowledge management, so the part that isn't talked a lot about, but we have a really sophisticated intranet and kind of, again, holistically harvesting the data that we generate. Not only reference data and knowledge that we can plug into our projects, but the data that, the metadata, in a sense, that plugs into the modeling and the design work that we do. So they're really integrated. So design tools, knowledge management. And then third, which is really never talked about at all, is our global infrastructure. So we have a really robust, really strong integrated network infrastructure. So we're on a single network. We have 6 global locations, and we operate as a single collaborative network. So if one goes to Shanghai or Hong Kong or London or Seoul or New York, any KPF staff can work as if they were in their home office. So we have really a wonderful integrated video conferencing, web conferencing, single IP phones. And it's funny, when I was the chair of the National Technology Conference Committee and the New York Committee, we talked a lot about networking and how do you do backups and all this kind of nuts and bolts of technology back in 1999. And that is really never talked about anymore because we've gotten so sophisticated with our design tools that kind of commoditized technology is not discussed. But truthfully, it's the foundation to how we work for sure, that this kind of robust global infrastructure honestly reinforces all the work that you'll see tonight. So I'll leave it at that. Again, tonight we're going to really focus on the design technologies. We have 5 kind of briefer talks, so we thought we'd have a nice a breadth of technologies that we're exploring and just discuss them for 10 or 15 minutes, and at the end we'll have questions and can talk about our technologies further. So again, thank you so much for the invitation, Paul. I really appreciate it. In 10 years we'll be back, of course, and hopefully have progressed. So thanks again. Ian will lead us off. Thanks.
Okay. So, again, thank you for coming. My part of the talk is about BIM and about IPD, I'm sure everyone in this room has attended a talk about BIM and IPD, certainly in the last year. The talk that I'm going to give for the next 10 minutes or so is just as a brief outline and a bracket for what the other members of the team are going to go through. My role at KPF is the firm-wide building information BIM application manager, which I work hand in hand with Nock, who I know is here tonight. I saw him earlier, dealing specifically with Revit and BIM, and my role is not just working alongside him, but working with the peripheral kind of how do we work and what do we work and who works on what, and you'll see those issues arise in the presentations tonight. So there's 5 of us here tonight, all having, some of us have more specialist roles than others. We're part of 600 people almost, firm-wide throughout the firm. We all work very, very collaboratively, not just within New York, but across the whole global network. We have 6 offices firm-wide. New York is the base for our operations, and what makes KPF unique for me and what I've seen in the work environments across I've worked extensively in London and New York, is the offices, they work very collaboratively and live on any given project. So obviously our offices, being an international firm, our projects are international as well as our offices. They range from all the continents, but where the projects are also influence the nature of our collaboration, the who works on what and how we do it. This, for example, is a project in Paris, France, Parc du Millénaire. We are currently working on this project live with London and New York. The BIM strategy is a very kind of total one for the firm. It helps us coordinate and collaborate so we kind of share each other's specialisms. The Revit server, and one thing I should note is the rest of the team are going to talk in a lot deeper kind of shop about the technicalities of the softwares and how they do it. But BIM is the heart of our, Revit is the heart of our BIM strategies and operations, with many kind of plural BIM, with a plural BIM approach. So when we're working live in London and New York, the Revit server serves as a live environment in which the whole office can work. So, and that goes the same for domestic projects too. The whole office have the ability to work simultaneously live in any given Revit model. So finally, the Asian projects too, and this example is the Lotte Tower in Seoul, Korea. And one thing I want to expand on working on the Revit server is that the huge breakthroughs that have happened in BIM, the big data, the cloud, which is a very commonly used term now. The big data for us means projects in Shanghai, Seoul, and the office working also live in this model. Now, Revit 2013 release, we've seen improvements in the latency and the ability for Revit to comprehend kind of the files being sent transatlantic and transpacific. So some very exciting developments just in the industry as a whole. And Revit Server has really provided a great capacity for increasing the intra-firm coordination. So not only intra-firm, the collaboration efforts are, many firms hinge their collaboration with external disciplines, the structural, the electrical, the plumbing, the mechanical, and we like to put ourselves in the heart of that, the BIM methodologies, where we use either Navisworks or BIM 360 or a range of cloud-based model collaboration tools. It's really important to us to have that information flow in the cloud collaboration, internal and external. So in this project, this is the domestic project. It's in Baltimore, Maryland. It's for the Maryland State University. The project, as you see, was a very extensive BIM environment. A lot of our projects are now. The Revit project's based in the Revit server, but alongside the external collaboration, we have the internal kind of knowledge bank, the KPF intranet, and the BIM procedures, the BIM execution plan are used as a base for how we communicate and how we collaborate. The collaboration strategies are at the heart of what we would consider industry standard, as thorough as what they are in this kind of current time. As you see on the bottom left, the slide shows the AEC UK standard for Revit sharing. It's a shared environment. This is a typical IPD, and it's based on whatever the client's demands are, or the client communication for their needs, on how we share and how we integrate. We have a strategy for the extreme live IPD, which comes out with the under the correct legal framework for the AIA contract, for example, the B195 and the C195, and just the live collaboration is a very exciting development that is occurring, and we do look into it, but this is the standard kind of procedure where we share each other's models in a shared platform. So as you have heard the word Revit quite a lot, I do like to emphasize that and I personally too, I have an extensive background in Dassault systems, and the firm has done a lot of projects in generative components, and I do like to advocate for a cross-BIM platform with a variety of approaches depending on what's relevant for each particular project. Most of KPF's projects, I would say, really hinge heavily around the exterior envelope research and the significance of the envelope, especially with regard to environmental strategies and the concerns of the client too. It also involves very, very close collaboration with the fabrication technologies and curtain wall consultants, especially for a project on this scale for the Lotte Tower. And Charlie's going to expand on his very thorough techniques he's developed in close communication with fabrication technologies, which involve the fabricators being able to use C+ scripting for their direct CNC cutting. Some very exciting technologies just in terms of raw integration in model sharing alone. So this extended to the structural research as well. In the Lotte Tower project, it is the heart, the exterior envelope of some very exciting developments in the physical and the digital world. A lot of optimization in terms of form, the environmental stresses that happen on the building, and how can we as designers best adapt to where this building's going and what it's doing and what it looks like. It's very important for the local geography and the local culture. So on the top right, you'll see a strategy that's really exciting, a very complex process that a team has worked on, which is a Grasshopper to Revit scripting workflow. There are many, many different options out there right now, some with just out-the-box add-ons, and some going back to the raw scripting C+ environment, or .NET, whichever one works. So, this exemplifies this process where we have a very extensive design process in Rhino, and Grasshopper is integral like a lot of firms. Our challenge is to bring it back to the mega scale, the large, the super tall, and and very often in a lot of the foreign or the Asian projects, the exterior envelope is a big focus of our design strategies. And here you see coming back in a BIM environment, not just the digital model, but BIM, it is significant, and the information and the metadata contained in our models we take very seriously, and seriously in terms of the collaboration that I mentioned with construction managers and what the metadata is as part of that Revit strategy, and just overall the communication. It's a language that is really a very significant part of the digital workflow. And so with that, I'm going to start to flow into the next part of the talk, the bit of the people doing the work day to day on each particular project. I would say I kind of sit on virtually every project that goes on in the office in developing a Revit strategy, along with NOC as per project by project workflow. And the environmental part comes in from start to finish of any given project, which is what Jerry is going to expand on now.
So to quickly walk you through some of the environmental design optimization strategies that we use at KPF. I'm part of our sustainability group, and the structure of that group within our firm is that it is a network development. So the idea is that there is a group of us working on sustainability full-time, and our main goal is to help implement strategies and analysis that will help that come along with the teams. Beyond that, we have an extended network that we're constantly trying to give software tutorials to and education to further that development so that they can eventually do some of the tasks that we're doing, some of the more simple analysis, and then we can spend our time moving forward with some of the analysis that we're doing. The idea of the structure within the firm is there is a lot of back and forth. So as I said, we're working on a lot of different projects with a lot of different teams, and at many different stages of development. So they'll give us a model, we'll run an analysis, we'll give them that model back. They'll tweak something as a result of that. We might do a more detailed analysis to see how that's developed. Beyond that, we're working with all of the different teams as well. So we're working with the visualization groups, we're working with our extended network, and we're working with the day-to-day teams as well. Beyond the software that we use, I think one of the things I wanted to talk about was the importance of the information that you're putting into that model and how that knowledge needs to be intelligent as well. One of the first things we do the minute we learn about a new project is we create, if we don't already have it, the weather data for that project, and we try to sit down with the team and walk them through what the significance of those images are. So what is the outdoor air temperature, what is the humidity, what are the passive strategies that will naturally extend the life of that comfort zone, what is the rainfall, the wind, the sun path, and the radiation. And these are all looking at a very standard distribution of these systems. And then we can begin to develop them for the individual building as the project develops. This information is also available along with a number of other pieces of data on our internal intranet, the idea being that beyond just working with us, that information is available for them any hour of the day, every day of the week, should they want to access it. One of the things that's very important, besides just understanding the context of your model, is understanding what is the climate that your model is in and what type of program that you have and what is the significance that is going to have on the modeling of your project. This particular example was in Shanghai, China, and it was an academic project. The climate had both a heating load and a cooling load because it does have a summer and a winter in this climate, and because of that and because of the program, that meant we wanted to mitigate some of the solar heat gain in the summer, but we also wanted to allow for passive heating in the winter. And that meant you needed to be looking at both of those conditions as you were designing your shading devices to allow for both of those options. On the other hand, this is a project in Abu Dhabi, and to a certain extent, it doesn't matter what the program is because it's a hot climate all year round. This particular project was a resi hotel and retail, and our shading devices needed to be effective year-round. This is an example in Beijing, China, which obviously does have a very distinct cold period that requires heating. However, it's a super tall office tower that is almost 100% offices, so it has very substantial interior heat load. So even though the way those shading devices are going to change throughout the year changes with that climate, it still needs to be mitigating that heat all year round regardless. And knowing that information is really important to how you set up the models, regardless of the software that you're using. This is just a quick example of strategic facade analysis using very quick tools to begin to develop some quick feedback for a team using Solar Tool and understanding what is actually going to be effective before we begin to actually optimize a shading device. So the red areas on the right are highlighting 3 different facades on an airport project in Nanning, China, and the idea is that none of these were true orientations and they were all curving facades as well. So the way they were going to perform was not actually a standard predicted amount. So the first thing we did was, again, look at that climate data and looking at the area where the coldest months of the year where some heat gain might be acceptable, and then looking at the times where there was the highest amounts of solar radiation, and laying those two things out together on a sun path along with the orientation of the wall began to tell us where those shading devices would be the most effective and at what times of the year before we actually began designing the shading devices. So this was just the quick result of those study, and the idea is that we're trying to maximize the effectiveness of those shading devices at the hottest time of the year, and they don't need to be as effective in the winter. And then that was the result across the building. This is looking at how we would begin to do some of those optimization studies at the scale of the master plan. So before any analysis is done, being able to sit down with the team and develop a list of strategies. This particular project was just outside of Toronto, so it's a cold climate where you want to try to maximize the passive solar heating, and coming up with a list of strategies that would help them to do that, you know, in regards to building orientation, in regards to program distribution, shadow coverage between the buildings, and the distribution of circulation space versus occupiable space. Once that had been implemented and a massing model had been developed, we were then able to model that holistically within the site and begin to say, well, these are the individual buildings that need to be tweaked to further maximize these opportunities. One of the other things that we do, as I mentioned, we work with projects at all different in all different stages of development. This was a particular project that is in construction administration right now. It is very much in the process of being built. However, about a week ago, when the client saw the mock-up, they decided they did not like the shading devices that were going to be used. The problem being that those same shading devices were what were also used for the lead energy modeling, which is very linked to this project. It's an academic project, so they feel very strongly that it meets the target they've set out. So one of the things we were able to do was go back and look at, well, what was the initial performance of the shading devices as they were currently designed, and then testing it for two of the variations they were looking at, and not only looking at is the overall reduction in radiation approximately equivalent, and we would probably have a similar effect on the energy model, but also looking at the breakdown of that material across the different facades. So if they wanted to have the option of changing the density on the different orientations, they could have that opportunity. So one of the other things that comes up quite frequently when you're using tools like Ecotex are some of the quirks of the software. So this particular example is looking at the fact that the software is running its values of radiation as a direct result of the areas that you're running it on. So you can see here, even if you add up the average pieces of those smaller ones, the average amount of radiation falling on them is actually the same as the bigger pieces. However, some of them are being registered as completely in shade, and some are receiving a lot more radiation. So if it's a smaller scale, then graphically it's reading very differently. So from my standpoint, what this means is we want our models to be subdivided in areas that are approximately equivalent, which can be an interesting challenge when we work with a lot of curving facades, and Ecotect is a somewhat clunky software that doesn't always allow you to have control over the subdivisions like that. So one of the workarounds that we've developed is subdividing things in Rhino, and then working with our visualization team, we then have tools that allow us to bring that data into Ecotect more cleanly. So this is just showing it's that same Rhino model that's already been subdivided, and it's then rebuilding all of those surfaces as 4-point squares in Ecotect and importing that data. That data is then able to run in Ecotect and import itself back into Rhino so that the team can work with that information and that knowledge database directly in their own model. And there you can see the model's been run, and then taking that data and importing it back into the original file. So one of the things that technology allows us to do is responsive shading device, and it allows the team to work with this information much more directly. So in this particular example, it was a faceted building model that was self-shading itself in addition to the context, which meant you had a very varied amount of solar radiation across all of the facades and even across some of the individual facades, the design team then developed different shading devices to correlate with those different radiation amounts. So they would have the deeper shading devices on the areas receiving the most sun, and the more shallow ones receiving on the areas that were receiving no or the least amount of radiation. And from a design standpoint, what that data allowed them to do is then play with the different aesthetic options. So looking at how that would then be distributed with 3 shading devices, with 6 shading devices across the facade, and with 12, and how those designs would then begin to be populated across a single building model.
My name is Charlie. A lot of my work at KPF encompasses working in some sort of computational parametric strategy. I work very closely with the environmental network in our office, and also very closely with the BIM individuals in our office. So part of what Garrett just presented, the developing tools of interoperability, that's one of the things that I work on, but also taking all of the stuff that I've done over the past 5 years or so, and being able to integrate it in systems where now it's usable for users. I've always worked in code, and a lot of times when you talk to computational people, they always talk about scripting and writing hardcore code, but it's usually a challenge to create an interface for everyone to use it. But now with Grasshopper, it's pretty easy to create plugins and develop interfaces so that no one has to go in and tweak your code around. You can easily attach parameters to that and so on and so forth. One of the tools I'm working on with the environmental network is this shading device calculator, essentially. And what it does is that we have an interface where it can take any panel, any orientation, and with a series of parameters, the louver depth, the louver angle, the roll angle, the panel angle, the orientation angle, so on and so forth, and essentially run through a series of different iterations, and it will output a number of optimal results. Some of those optimal results may not be visually appealing, but that's why it outputs a number of results, so that therefore the designer can take kind of take control and choose what is aesthetically appealing for the design. Another aspect of what I do at KPF is trying to take the digital to physical. Digitally, we can do basically anything. Between the animation software and the geometry software that's out there, we can model almost anything, but how can we make that reality? Forces and physics and materials and so on and so forth. This is a project in Baltimore at the Morgan State University. It has a pretty limited budget. It's pretty tight. And there are these, I don't know if you can see them, there are these metal panels throughout the facade. And these are perforated metal panels. And the client loves them. And where the concept started with taking this, this painting. We chose a portion of that painting that we thought would be a good contrasting option, and we just essentially took the pixel values and generated perforations. But what we also did is we thought about the constructability factors. If you have more than 40% perforations within the panel, you start to lose structural integrity depending on the thickness and so on. We also looked into, based on that image, looked at the different perforation sizes. We looked at whether it was a regular orthogonal grid, a staggered grid. We took into considerations if the shapes overlap or not. And this is a laser cut mock-up that we did in the office, and we just spray painted it and kind of just put it up against the window. So then based on that, we started talking to fabricators to see how much this would cost and how can we bring the cost to within a budget. So we looked at 2 options. One was if it was die punched, and one if it was plasma cut. And basically we got to a point where we were able to control a lot of the parameters to kind of sway sway the figures in our favor. Plasma cutting is based on time, and die cut is based on the number of dies. So we limited it to 4 dies and gave each of them a different rotation to still give us a variable, a variable kind of perforation. And then for the plasma cut, we didn't really reduce the perforations, but we tried to hone in on kind of like a time factor. They're still out for bid, and when we did the drawings, we put both options out there so that there are alternatives to not just one necessarily method of fabrication. There's another project that I'm working on that I can't really show images about, but we're essentially going straight from geometry to machine code. A number of people said that this wouldn't be possible, and a 30-minute conversation with the technician, we were able to go back and forth and figure out what the machine needed and what needed to be exported from the geometry, and we essentially kind of figured it out. There's 1 or 2 minor hiccups that we're ironing out right now, but otherwise it's been a pretty successful project. A little hint, if you look at architectural record, you'll see an image of Bill Pedersen. And that's pretty much all I could say. A lot of what I do also is parametric modeling. So in this case, for the China Resources Tower, I work on a number of different projects. For this project, I didn't have a lot of time, so what I did was I just essentially put an interface together which the design team can use. So basically, between adding a few diagrams, some color coding, and some instructions, the team were able to use this to go through a series of different iterations for design changes. And this is in the early schematic stage. So we can control the massing, we can control the diagrid expression, we can control the areas, and then this is cutting the section through the building. And then as time progresses and the project progresses, we get a little more complex, where we start drawing blocks, start exporting DWGs. So essentially, even though in the very early stages of the project, and this is still an early SD, we can control the project pretty well. And this is just an image of showing all the blocks and all the plans being generated. This is a project that I've been working on for 3 years, and we just finished the CDs for the large tower. It's a 2-phase project. This medium-sized tower on the left, that's the cladding will be done shortly, in a matter of days, and the piles for the rest of this have already been put into place. But essentially, what this diagram here shows is kind of how we can take a concept. In this case, it was the concept of the sails, and for the facade expression, it was this calligraphy figure, which is called the double happiness figure. And we can take a concept, include parameters to it, put it into a model where we can start to quantify these things. Curtain wall panel similarities. It is a double curved building, so we tried to see how can we find similarities within curtain wall panels within the pattern itself. The pattern is 28 panels that are unique, but once you go across the entire facade, you'll find similarities. And then going into drawing, generation, mock-ups, and fabrication. I'm going to switch to this real quick.
bring Sally down. Last done start, gotta tell the ground. Bring Sally up, bring Sally down. Last done start, gotta tell the ground. Sally up, bring Sally down.
The one great thing about the process behind all of that was that when it came to the shop drawings, we were talking about fractions of millimeters off by being on the curtain wall panels, to a point where one of our colleagues started making fun of us. This is another project in Beijing. It will be the tallest tower in Beijing. We do a lot of curtain wall studies. And for some of us, it's easier to do quick manipulations in one program as opposed to another. So a lot of the studies were done using Rhino and Grasshopper and some scripting. But then the project had to be a BIM deliverable. So how do we go from, very free-form, intelligent, but the intelligence isn't attached to it anymore, kind of model to a more intelligent method? And what we've developed was essentially a routine where we can export all the curtain wall panels into a spreadsheet and read them in and repopulate them in through Revit. Oh, wait, and I got one last. And this is just kind of showing the link that we have, that we've developed. A little bit of a note on this. A lot of the Revit stuff was helpful. Because we do it on a number of projects, but it was also it was great working with a couple other individuals within the office to help develop this. And if you guys know Nathan Miller, his blog was very helpful in helping us develop this and put this together. Everything, of course, is time-lapsed. Yeah, no. My version of time is slightly different than most computers. And that's essentially, we can be able to take curtain wall panels from one software to another. In this case, these are just generic panels, but we also have another routine that can go in and attach families to it. So when we finally finalize the design, within the last day or two, we can run the last script, get the final panels, and print out drawing sets, or transfer the Revit model. I think that's the end of it for me.
So this is probably the only design-related joke that I've ever read and heard in my life. I think what I like about it, though, is that there's a really acute sort of sense of observation, that there are certain things that we overlook or sometimes take for granted. So I'm sure you've probably seen your own version of this. and where Revit and sort of state were put in the middle of all this. And I think that for a long time people are used to kind of thinking of this as tools. I think in recent times what we've been looking at is kind of the development of a language, more so, and in particular with what we've been doing is kind of a visual language. So I'm going to sort of move from micro-modeling to kind of macro-modeling, and move from 3 projects. The first one here was at the end of DD. So at this point, what I'm trying to sort of show here is the 1 to 20 scale, which Revit is a really good tool for. On this, we tend to also incorporate detail components, which is sort of a 2D method of drawing, as well as a 3D method. So in some cases, we have our slabs and our beams and our curtain walls that are all 3D objects in the Revit model, but then we also have some details that we're drawing, which are just 2D information. This was a client in China, and unfortunately I can't sort of show the overall building for confidentiality reasons. But as we were submitting all these documents, they were also requiring us to constantly sort of give them visual and highly articulated sort of 3D models. So this is kind of when Revit really becomes a drawing tool and is often used much like AutoCAD. So these are all detail components that are not really existing as 3D objects, probably for the simple reason that it would most likely crash our models. But what we managed to do was take that 3D information that existed in the model and along with the 2D information begin to overlay them. So in the case where there are objects going in the XY direction, we would simply shell. In the Z direction, we would extrude. And this also, I mean, there was a point when our client actually, said, guys really don't need to build these things for real. So it was great that we kind of managed to sort of fool them. So our stack joints, in this case, we had screens that were sort of being developed that were cladded in this aluminum veneer that was made to look like wood. So it was a really effective tool and a very effective visual tool to kind of show our design intent. So moving to a slightly larger scale, this is the same project. We were starting to look at 2 lobby interiors, one a residential lobby, and the one an office lobby. This was all in the same sort of mixed-use building. Again, as we're submitting these drawings, we're still going through a design process, and this process was very fast-tracked. We moved from SD to DD in roughly about a month and a half, 2 months. So it was a very intensive process. So we were moving from sort of, and this was our first use of conceptual models that we were kind of micro-modeling on the side and incorporating and linking into our project. So here they were asking for different iterations of screens in the residential lobby. One was a little more classical in terms of its proportionality. And then the same for the office lobby. Again, we could sort of quickly move from having these very basic forms that also existed in our Revit model to showing them highly articulated. And keep in mind, everything shown in here, except for the people and the plants, exist in our Revit model. So they're actual depictions of the documents that are going out. So for the lobbies, they kept asking for more classically themed things. So we decided to try and fool them by just introducing more traditional furniture. But again, it was really effective, and they tended to really be excited about this process. The last project right now is a project that we're in conceptual design for, and we're about at our midterm point. So in this case, again, I think now moving with the design option at the overall building scale. So the client and the culture being what it is, the demand for several options and several iterations can be, again, somewhat arduous process, very intensive as well. we also had sort of a very strict solar envelope that dictated the shape and some limitations on the height. So from here, this was kind of our attempt, our first pass at sort of using and incorporating conceptual modeling. So on the left-hand side here, this was kind of our digital napkin. So we just had profiles that we would set on different levels, and we could fairly easily change these profiles, and even new users could come on, and as long as they could draw a line, they're pretty much okay and safe. Then we would take those lines and then essentially loft them, just simply create forms. Those would be brought in as families into the project itself. Within the project, we could then extract mass areas. We could extract the form. We could articulate the facade. From there, we would then export it, bring it into our max files, and then extract it. And this whole process was fairly fluid and was constantly changing. And at any given moment, you know, this could be done roughly in about a day once we had all our settings done and all the outputs. So, you know, this was kind of, these were our design options, and it's fairly extensive to sort of give you an idea. We've archived several of them. I think now we're a little leaner. Within this, of course, there's a lot of management regarding all your view types, and in particular how we're extracting this information depending on our need. In this case, it's very sort of visually heavy, and therefore that's kind of our primary focus in terms of just our exports. This sort of, you know, again, along with kind of this process and, you know, trying to be fairly disciplined about how everything is being brought out, enabled us to kind of flow into our max models, not only for our internal use, but as well when we were handing this out and handing this over to consultants and rendering companies and so on and so forth, where everything was named and everything was assigned through subcategories. In parallel, we also had all our materials being clearly outlined and named according to all the subcategories that would go back into our options. In parallel with working with our environmental department, what we could do as well, and we've started using Visari in parallel with Revit, is we were taking our forms and actually running them through digital CFD models. This process can be quite costly. So, you know, I think it can give us, and the accuracy, I think, is still up for debate. The thing with this is that we can at least get a sense of, are we making the right moves, and how is this informing the shape of our building? So we could run it through that. In parallel, again, incorporating a lot of what the environmental studio is doing, we were able to run the models through. So there is kind of a plugin for it. We have the benefit of actually having the software, so having much more precise numbers. And then we get our final results that we can give out.
Hi, my name's Justin Whiteford. Sorry, I'm just coming down with a cold, so apologies for sniffles. I've been working at KPF for 5 years now. I've worked in Revit since my first day at KPF, by no fault of my own. I only knew how to hand draw when I came to KPF, so I immediately trained, worked on Revit, and since then basically stayed on exterior wall modeling. Since then, I'm going to focus today on Hudson Yards, which is a project that's going on the west side. Working on the exterior wall, and I've been working on it for about 1.5 years now. We have the onus on this project of it being in our backyard and having to look at it all the time, and also chasing it all the way through CDs. So having to work with it every day, having the clients in our own office, having the clients in our own town, you're really knee deep and elbow deep in everything from massing to having to get drawings out very quickly to having to get renderings out very quickly on a day-to-day basis. During my time at KPF, I've spent a lot of time working on sort of office-wide techniques on how to use Revit and how to leverage the software in a way that benefits us and each of our different processes, whether we're working on a domestic project, a project in Shanghai, you know, multiple office, everybody in one office? Are we using this software to only design and schematic and pass it off, or are we going all the way through CDs with it? Again, I've worked on exterior wall models for the most part, so they tend to take up the most of KPF's portfolio as well. So we tend to split these models out separately so we can carry them on longer, that they can live their own, sort of exterior wall package lives separate from core, structural, everything else we're, doing at the landscape and site development areas. The initial reason I got into Revit was to develop many options, which is what a lot of first year, second year, third year people do at KPF. It's just facade option after facade option, and Revit obviously gives you the capability of extrapolating different options for a similar scheme very quickly, and then exporting them with 3ds Max, rendering them in Revit, getting drawings out very quickly. This is a process that we've been developing from team to team, and it's become quite successful for projects that are mainly in Revit. That means they're not using a Rhino import-export technique or going back and forth between CAD. This gives you the ability to model in other softwares and bring it in, and then apply surfaces, curtain panels, and then specific instance parameters and design, parameters to the panels that you're creating. So we start with the mass family on the right, and it's given all of the site-specific design parameters, orientations, surface areas. You're getting your floor areas out of that. We apply curtain systems to them. We decide on things like curtain system types, modulations, and their edge conditions, and then we apply these curtain panel families to them in Revit with every type of parameter available to us that you can possibly program into a family. Specifically in Hudson Yards, we've defined the massing in any number of softwares. We've been in Revit for a while now, but it started in Rhino, and I'm sure it's gone through Max many times. We define our modules, which basically gives us a skeleton of points that we can attach to all these modules that are different sizes and pieces on the building. We extract those control points, and then we use those points to apply types of walls and then study them individually. This application gives us the ability to schedule and extract just tons of information out of every panel. Each panel knows, because we tell it, what its mullion depth is, what its spandrel area is, what its orientation is, whether it's a corner condition, whether it's a parapet condition, if it's got louvers, what its width, length, height area is. So that's one way we really benefit from using Revit is just the ability to constantly schedule every panel on the project and associate as much information as we can. And especially being on a project that we're going to be drawing all the way through construction documents, managing this information and having it constantly available, whether this project is going to be around for 5 more years, is the staff going to be around for 5 more years? So people are always, new staff and old staff are constantly accessing the same information, and everything's tracking through, so nothing's getting lost from person to person, or from, model upgrade to model upgrade, or Revit 2012 to Revit 2013. I'm just going to focus on the sort of paneling types that we've been developing on this wall and how we're using Revit to sort of leverage the ability to keep track of all this information. We basically have 3 panel types. One is a flat taut curtain wall that you see everywhere in New York City. The second one is a shingle wall, which presents a lot of interesting little quirks about it to design. And the third one is also a shingle wall, but we shingle it in 2 directions, in plan and in section. And the software, how we develop these panels, gives us the ability to change these parameters, to the extremes that the client will let us, to the extremes that the facade maintenance folks will let us, and to the extremes that we can still maintain U values on the wall that are appropriate, all while balancing the aesthetic design with it. So the first panel is a flat wall, but given that it slopes, in any different orientation, we as humans like to put things on flat surfaces, so we need to tell the panel that the horizontal surfaces need to stay flat. So it's fairly simple. It's got 2 orientations currently. It used to have 3 and sometimes 4. And basically, we only need 4 control points on the wall or on the surface, going back to that grid layout. So basically, we're able to just be very specific about what happens at each point by modeling the mullions, the spandrel, the type of glazing, everything within one curtain panel. This is a system that Nathan Miller developed, Case has developed, Zach Cron develops it. So it's very out there on the blogs. So we've sort of adapted it as a KPF standard way to model our curtain systems. The ability to have a one-to-one relationship between what you're drawing and what you're rendering and what you're, showing Bill Pedersen on a day-to-day basis is all of it, all the argument that I ever needed to continue using Revit, because the second you're having to manage these drawings and update these renderings on a day-to-day basis, a software like this is really the only way I could get it done. The second type of wall is a shingle, and for all intensive purposes, we're just shifting a plane away from the face of the building every module, and we apply parameters to this to tell it how far to shift and what the slope of the building is to maintain horizontality on all the surfaces. And there's 3 types. And basically, since we're just pushing back one surface, we're basically adding 2 control points to every panel, and we're just controlling those points in addition to the 4 that are set out by the module. And again, there's this one-to-one relationship that gets maintained through our FBX linking to Max, or whether we're rendering directly into Revit. And the third panel is shifted in plan and section, and also the glass overhangs. And so there's parameters associated with all of this. If somebody gets daring overnight and wants to extend another 2 inches, it's not something that is going to take 2 weeks to track through all of our drawings. It's immediately updated, push of a button, kind of adjust a parameter, adjust 2 parameters on this type of wall. Since it's pushing away from the facade in plan and in section, we need 3 additional points to control the facade, and basically we can achieve the overlap that you see on the right. And this is what it looks like in rendering. So another great thing about Revit is that it really does well at identifying atypical conditions for you. As long as you've put in the right amount of information, you can say, okay, when is this edge length not enough? When is this thing out of plane? When is the surface area not accurate? And you can really do well to identify and extract this information and basically identify problem areas before they come up. So this is how we are dealing with the crown of our building, which are obviously atypical curtain panels. Then we're able to develop, whether it's in office or contacting Case or contacting Autodesk or any of our go-to problem solvers, to develop a way to be able to model these things very quickly so we can keep up our pace of constantly changing. This technique we sort of call it piggyback. We just piggyback one panel on top of another one since we already have it modeled, and then we're able to sort of chop that panel because it's associated with the next one down. And same thing for the all the edge conditions and corner conditions on all these panels. We are able to basically analyze how efficient our design is. We originally used this technique to find the slopes of every wall. So as the modulation changed from 3/6 to 5 foot back and forth, we would set limits on how often we wanted panels to repeat, and that would set the slopes of the wall. So this building has a tendency, as we've changed floor to floors over the year and changed the glass types, glass manufacturers over the year, we've been looking at sort of optimizing this mass, and then we can always go back to the panelization of it in the same software and immediately extract how many atypical panels do we have that are not following the rules, and then we can go back and stitch these techniques back together per panel type by piggybacking onto adjacent panels. We can still maintain surface areas, and they're still very clean for the drawings and renderings that we have to constantly extract. So all of this work we do, and I do on a day-to-day basis, like keeps these pretty pictures up to date and accurate for everybody on our design staff who needs them constantly. And then hopefully it's applying to the pretty picture overall for the entire site. Ian? Thank you.
So I'm just going to give the closing remarks. I just wanted to emphasize the fact that we do have this larger firm behind us. The collaboration is really the exciting part of our efforts. As I say, almost 600 people in the firm, and firm-wide, obviously only the New York office are in representation tonight, but the knowledge sharing that each individual office brings is integral really to how we work. In each project that we've shown tonight has a mixture and a variety of each office around the world working on it live or individually at any one point. And so the bringing back any technological innovation back to the social factor is really the key and the most exciting part of what we do day to day and what keeps us interested in developing and researching what we do.
Okay, we're going to have a quick break for just about a minute, and we're going to have a question and answer session, and I will go around passing a mic. And for those of you with questions, you can address them to the KPF staff here tonight. So, let's need the mic. Let's see. Hopefully you'll stay. So, bear with me for a second. Okay, great. All right. Are there any questions that you would like to address? Yeah.
Just curious, if we take just your New York office, how many people are involved in what you are doing in the digital representations of the project in broad sense?
Yeah, that's it's a big it depends factor on that. And for instance, some projects.
If we could just please keep the discussions to the staff, it would be greatly appreciated. Okay. So the question was, how many staff are involved?
Right. So yeah, it is the it depends factor. To nail it down specifically, the Hudson Yards team, it's a very significant project in the office right now, and they, as a New York-based team, would be 40, maybe, day to day. But then the broader, JERA has made efforts too in the environmental part of it. We do have certain people that specialize more than others. That float across PAN projects. That aspect is actually much smaller than some offices. We do like to encourage live project deployments for each individual specialist knowledge base. So, yeah, it ranges from anything from 2 people to 40. So.
Okay. Next question.
I actually have 2 questions. First is, could you explain how you collaborate with the engineers using these processes? That's one. And then the second one is, what goes out the door to the contractors in terms of documents?
The question, there were 2 questions. One is, how do you work with contractors? And how do you get the information out the door to get the engineers and, the engineering staff and the contractors, and how do you get the information out to them to actually fabricate and construct the designs?
From the fabrication point of view, typically the conversation starts as we show them what the design is, and then we ask them what do they need. This whole idea of just drawing something, giving it to them, and having them redraw and remodel it is just a waste of time. It's very inefficient. For the Morgan State perforated panels, we gave the fabricators the files, and we got feedback from them. And one of them said that they've never seen files so clean, which essentially meant they had very little pre-processing time needed on those files. When it came to the other project, it goes straight to the machine. So we can go from geometry to fabrication in certain instances. It really depends. This discussion happened about 3 or 4 months ago at one of these sessions too. It really depends on the designer and the contractor / fabricator. If both people are on the same page and they both have the same mindset of doing something interesting, collaborating, and making each other's workflow easier, then you can do something really interesting and very seamless. If the fabricators don't have the technology, or you don't have the technology, or the machines aren't in place yet, or something or other, then you kind of have to go a little bit more on the traditional route, essentially.
Yeah, our engineers are in the office a few times a week. They're not in Revit, but we work with them with Microdesk to get their information into Revit that's coming into our file, so their backgrounds and our backgrounds are constantly live back and forth. I've worked on other projects where the MEP engineers, for instance, or the structural engineers are in Revit, and we exchange files every week. They come in clean. They're constantly in our backgrounds, which sometimes to your detriment, because you can see when people are making errors as soon as they're making errors. But that also varies from project to project. It depends on the level of expertise of the engineers you're working with. It depends on the size of the project, how global it is.
Yeah, and I would say the majority of our integrated projects, and industry-wide, I'm not going to fake it, people are doing IPD Lite in nearly every project for IPD out there. They're under the A195s, which you have to send models. I mean, I would love to set up an integrated server environment where everyone is working live in the model, but and working live with the engineer, to answer your question specifically. It's a fantastic environment when we do work like that. The errors and just the knowledge that you gain like that is very exciting for the team. However, we often need owners and clients to really pick it up and to take us there with that IPD contractual framework. On a project, on a firm our size, we have to take the legalistics very seriously in the integrated project contracts. The AIA have the forms to do so, and when we get the opportunity, we go there in full integration.
Hi, first of all, thanks for showing some really great work. It's really good to see all of the sort of the range and the depth that you guys are working on. My question pertains towards sort of sharing that knowledge. So Jerry, you mentioned sort of in the sustainability group that you sort of have a core group, then you cast a slightly wider net, which I suppose in turn is intended to sort of communicate to the larger office, so it goes out in ripples. I'm just wondering if you have any strategies for the whole design applications and design technology group that way? Is it similar, or how do you handle sort of that diffusion of knowledge?
I can speak for the Revit side of this. For the past 5 years, I've been developing our project library, which seems every year Revit sort of takes a step farther than what I'm able to make a workaround for. So it's sometimes self-defeating, but we've come up with a large number of panel types, parameter types, things like that we just embed into our templates. So when new projects do come on board, they're hopefully learning from everything that myself and the other guys at the office like me are making on a day-to-day basis, and say, okay, that really works, and you can reuse it over and over again, and this is how much information you can embed back into it. So people, in terms of building a KPF library, we're able to feed on each other's successes and failures a bit.
We just launched several months ago a pretty extensive digital library on our intranet, and it has anything from New York City building codes documents to rendering materials to BIM information to you name it, you could probably find it on there. Another thing, is taking all of the stuff that we've done, and whether we do it as standards or plugins, or rather than just giving somebody a file and good luck. We try to make it as user-friendly and demystify the process, because something's only complex until you understand it. Once you understand it, it's not complex anymore. So if you demystify it, it removes the hesitation from individuals, and the knowledge spreads pretty quickly.
Yeah, and I would add to that, we have certain efforts to make library components at any one point, but we have, like a lot of firms, we have a core BIM user group within the firm. About 40 people turn up to the meetings regular basis, about once or twice a month. And it's a discussion of what do we need to collect, how do we do BIM as a firm, and it's a very kind of social process. Now, the ongoing effort for the library and the challenge for a design firm, I've worked in manufacturing and construction where the library is the base of your business. But for a design firm, the reason why a client comes to you is because everything's different. If you do a building that's been done in a certain way before, the client doesn't like you. So for us, the challenge of building a library is making sure we really hit that base formula and the base usefulness per project, which is a very, very tough challenge for the mass custom business effort. So the heart of it is just ongoing social effort of what do we want to collect as a firm.
Yeah, I just wanted to reinforce, our overarching effort, again, is to integrate these technologies into the process, our daily process. So we do make a large effort to get as many of the team members as we can to be up to speed with these technologies. Of course, these folks are like the stellar users in the office, but in fact, there are other folks in our other offices and in New York that are as good or are getting there. But again, our goal and our objective is to integrate these into the process and to make, we do Grasshopper training, Charlie in particular. We do a lot of Revit and Rhino and other technologies to be sure that everyone has these broad tools available.
It's one more thing I wanted to add about that was that a lot of this stuff is as reusable as we can make it. We're still a design firm, so as often as I've given people curtain wall panels, they want to break them and make them their own way. I never knew there were so many types of ways you can make fins until I came to KPF. It's just every time you make it, somebody wants to make it a different way. So we don't always. The library is important in terms of how much energy we spend building it up, but just as important are these monthly meetings that we do with other BIM users and other juniors in the office to sort of teach them methods so that they can become designers rather than just pick from things that have already been done before, because no matter what, the senior designer will always want to tweak it, change it, use it in a different way.
Any more questions? A phone-in question. Well, if there aren't any more questions, it's been a very interesting evening, a very thorough and detailed presentation of your technology work, and kudos to you, and keep it going, and thank you very much. James, I can assure you it won't be another 10 years, although I did joke with James that maybe Charlie in 10 years could design a walker for me. So. Well, thank you all for coming, and we'll see you next month, which will be Archtober. And keep on the lookout for a special symposium, which will be on a Saturday in mid-October. Thank you very much.